In this question, we're told there's a satellite around an unknown planet. So we have the planet, and there's a satellite in orbit, like so. Its speed is 64 kilometers per second. And the radius of its orbit is 2,100 kilometers. There's a second satellite, identical, that has a circular orbit at a radius of 8,400 kilometers. So we can see that's a lot farther out. 4 times as far. So 2 students are discussing how the speed of the satellite might be calculated. So let us think for a moment about how we might calculate this. What we have is circles, and there are forces involved. So if we realize that the centripetal force is the force of gravity, the centripetal force is mv squared over r, and the gravitational force is big G, big M, little m over r squared. So we're considering what the m's are. This m over here refers to the mass of a satellite. This mass over here, the little one, also refers to the mass of the satellite. So those would cancel each other out. And the r in this case, both, this is is from the center, the radius of the orbit, and is the distance between the center, so they're equal to each other. We end up with v squared equals gmr over r squared. R's cancel, and we're left with v is the square root of g big M over r. So that's the relationship we have, looking for the velocity. All right, so Lewis says the speed of the second satellite cannot be determined. Well, is that true or is that false? Let's see, this mass refers to the mass of the planet. The G refers to universal gravitational constant, so that's good, we've got that. And R, we're given is 8,400. The mass of the planet is not known. So it appears that Lewis is correct. So we would say this is true. Mass of the planet, unknown. We need to know the mass of the satellites and the unknown planet. Unknown planet, true. The mass of the satellites, false, because they drop out. So again, with these types of questions, we break them down into the clauses, determine whether they are true or false by themselves, with a reason for that. So Marcia says, but the mass of the unknown planet can be calculated using Newton's law of universal gravitation with the speed and radius of the first satellite. So let's see if that's true. We know the radius. We know the universal gravitation. We don't know the velocity. But if we did know the velocity, we could find the mass. But we do know the velocity. That's right. We're given the velocity is 64. So we know the velocity, so therefore we can find the mass. So the mass of the unknown planet can be calculated, the speed and radius of the first satellite. And that is just absolutely true. We have to do that first, but then we can calculate the speed of the second satellite. So if that's true, we can find the mass. We can put the mass in here, and that is true. We can get that. So everything that Marcia says is true. Now it comes down to what we're going to write. Evaluate the arguments of Lewis. So we're going to start out by saying Lewis, the first statement is true, can't be determined without the mass of the planet because v is the square root of g over big M and r. And M and V are unknown. We need to know the mass of the satellites and the unknown planet. So It is false unknown satellites because little m's drop out of the equation. But true that we need the planet mass. So that's the level of detail we want to provide in our justifications. So Marcia says, but the mass of the unknown planet be calculated. That's true. Because V equals square root of GM over R. If V and R are known, which they are, then M, the mass of the planet, can be determined. Now we want to define what these terms are whenever we can. So if we say use the letter like the mass of the planet, put it in real terms. And then she is also correct, true, using this M planet, which is the same for both satellites. G, M, and R are known, leaving V, and that's V equals the square root of G, M over R. And so there we're being very thorough.